Okay, hello everyone. Our topic is our disk. I'm 0710012 He Chun Yo, and I'll be doing the practice part of the project. And our aim in the project is to prove that the result from the equation part and the result from the animation part are right. And to prove that, we have to design a lot of scenario and apply our disk into it to see that if our results are right. So we first record our rotation, our spinning of the disk at 240 fps frame per second, and by that we can observe the cycle at different heights of the coin, like 1/3 of the height, half of the height, 2/3 of the height, and well, we can calculate the frequency and get the angular velocity. So we get 4 different coins, which means 4 different disks and 3 different rotating platform, rotating place. And this is how we do it. We first calculate we first find the initial height of the coin, and later we'll find 2/3 of heights, half of height, 1/3 of heights, and find their individual cycle, individual frequency. Okay, so this will be our result. We have 36 data here, quite much, a lot of time in. So first we'll discuss the most simple part, same coin, same platform, but different height. From the table, we can see clearly that when height decreases, the angular velocity increases. So when height decreases, sign decreases and angular velocity increases, which correspond to our equation. Okay. In the second part, we're gonna discuss different coin but on the same platform. We can't compare the data directly because every coin, every scenario have their different initial angular velocity. So we have to compare the examples which have similar initial value. So I choose the $5 and the $10 on the desk, which have in similar angular velocity of 2/3 of heights. I know it's not the initial velocity, but I think it's close enough. So we can see that the radius of $10 is obviously much bigger than the radius of $5. So, and from the data here, we can see that if R increases, the angular velocity decreases. And with our result, we can see that it's correct. So this part corresponds to the equation 2. In the last part, this is what the equation part didn't cover, because the equation part is dealing with the ideal part, but in reality we have to deal with the friction. So we choose 3 platforms, which means 3 friction, and similar to the last part, we can't compare them directly, so we have to choose examples which have similar initial velocity. So this time I choose $5, which on table, on desk, and on mirror. The friction on desk is obviously more larger than friction on mirror. And by the data, we can see that the angular velocity on the mirror is much bigger than the angular velocity on the desk. So when friction decreases, the angular velocity increases. And by theorem, with smaller friction, energy waste during the conversion from potential energy to kinetic energy is the spinning energy should decreases. So more energy in spinning, the angular velocity should increases. And this part sure corresponds to a theorem. So I think our practice part is quite successful. And this is my part. Thank you for listening.